All right, video on Lewis structures. Here's how to do it my way. Now, if you don't like to do it my way, there are several other videos out there that can help you. I just like my way better than any other way, so I'm going to teach it that way. Yay. All right, Lewis structures. Here's how to do them if you don't know how to. First of all, main important factor here. The least electronegative, except for hydrogen, will always be your central atom. Now, what that means, electronegativity increases as you're going towards fluorine on the periodic table. So it has a periodic trend just like ionization energy does. It increases as you go across, and it increases as you go up. So it's going towards fluorine. Now, electronegativity does not pertain to the noble gases because those technically in most cases do not bond. Some of the bigger ones will. You will see some Lewis structures for some of the bigger ones, but electronegativity does not pertain to those. Least electronegative goes in the center. Now, I like to follow a step-by-step process when I do this. Oh, God, come on. Get out of the way. All right, step-by-step process. First thing, you add your number of valence electrons, and that is equal to your total electrons. And I'm going to do a couple of examples so that'll make sense, okay? Step 2, your least electronegative goes into the center. Step 3, you then bond your outer atoms and subtract those electrons from your total electrons. This might sound weird now. It might not make sense, but I promise it will when we do a couple of examples. Step 4, we fulfill the octet of outer atoms and subtract those electrons from your total electrons. So what we're doing is we have our total number that we can use. As we're bonding, as we're fulfilling octets, we're going to subtract those total number down. We're going to subtract the ones that we've used. And our goal is to get 0 at the very end. That means we've used all the electrons that we have to use. And hopefully everything's octet is going to be fulfilled. Now, when you get to step 5, after you do all those steps, if your total electrons value is 0, if I've subtracted it all out and it's all equal to 0, double check your octets. If all of your octets are fulfilled, meaning does everyone have 8, except for the exceptions? Do I have an expanded octet? Can that have an expanded octet? If you double check that and all that's good, and your total electrons equals 0, then that means that it is a valid structure. You're done. However, if when you're subtracting all of those total electrons out, and if it's a negative quantity, meaning you used more electrons than you had to begin with, you're negative in the amount, then that means that you might have to do a multiple bond somewhere. So you're checking for things that can do CNOPs, meaning you're checking for things that can have multiple bonds. So you go back, you fix it. If your total electrons at the end of all this is a positive quantity, meaning you have electrons left over, you fulfilled the octets, the central atom's good, the outer atoms are good on the octets, then you check to see if that central atom can have an expanded octet. If it can have an expanded octet, you're going to put those electrons on that central atom, the remaining electrons on the central atom. So this is our step-by-step process that we're going to do. So I got a couple of examples to work with you on this. So example 1 is HF. So HF, let me change the color, I don't want green. HF, there's only 2 elements there, right? So we will not really have a central atom. If I had to choose a central atom, that would be fluorine, because even though it's the most electronegative, hydrogen can never be in the center, technically. The reason why is because he's just quite frankly not big enough to hold all the electrons. So very first step, add number of valence electrons and get my total. So hydrogen has a total of 1 valence electron, and fluorine has a total of 7 valence electrons. So if I add those values together, that equals 8. Now, this means that I have to use no more, no less then 8 electrons in my Lewis structure. And that has to fulfill my octets of everything. All right. Now, step 2, least electronegative in center. Well, we're not going to have a central one. So we're going to say H and F. That's all we can do right here because there's just 2. Bond the outer atoms and subtract those electrons from your total. So we're going to put 1 bond here. Now, in a single bond, I've used 2 electrons. So I'm going to subtract 2 from here. That means 8 minus 2, I have 6 more to work with. Okay? I've used 2 out of the 8. I have 6 left to use. Next step, fulfill the octet of outer atoms and subtract those electrons from total electrons. Now, hydrogen is an outer atom. He only needs 2, and you see how he already has 2 in this bond here. Fluorine, however, needs 8, and he only has 2 currently. So I'm going to put 1, 2, 3, 4, 5, 6 electrons there. Now you see that fluorine has 6 plus the 2 from the bond, has a total of 8 electrons surrounding it. Therefore, his octet is fulfilled. He's happy. Now, in that process, I used 6 electrons to fulfill the outer atoms' octets. So now my remainder is 0. Since my remainder is 0, I look at step 5. I double check my octets. Fluorine is good. He's happy. Hydrogen's good. He's happy. So that means that is a valid structure, and I'm done. All right? So this is the process we're going to go through each and every time. Now, is subtracting each of those amounts really necessary for AP? No, I just wanted to show you that it's a good way to check yourself, a good way to check for CNOPs, a good way to check for the expanded octet. Now, what I do highly recommend is you always do number 1. You always add your total electrons. Reason why? Some of these things will look like it's just like a really simple bond, simple Lewis structure, but they're a little bit more elaborate. Maybe they have leftover electrons at the end or something like that. So that's why I always suggest to definitely do number 1. Subtracting all those amounts out at the very end is not really necessary, but it's a good way to start out. All right, so let's go through example 2. Let me see if I can clear this out here. Oh no, that's not what I want to do. Maybe, oh yeah, there we go. Got it. Sorry. All right, example 2. We're now working with CH4. So step 1, add those valence electrons. Carbon has 4 valence electrons. Hydrogen has 1, but since there's 4 of them, I say 1 plus 1 plus 1 plus 1, which is equal to 4. So that's 4 total for all of my hydrogens. So that also equals 8 electrons. I'm just going to put T for total. Okay. Now, what goes in the center? The least electronegative. Hydrogen technically is out of this, but hydrogen cannot go in the center. So I'm going to put carbon in the center, and I'm going to bond my hydrogens. So hydrogen. I was going to try to be nice and neat, but it just takes too much time. There's a hydrogen, and there's another hydrogen there. Okay, now how many electrons did I use to bond all of those? Well, I used 2, 4, 6, 8. So I used 8 electrons to do that. Now I've already approached 0. So I need to double check and make sure that all of my octets are fulfilled. Well, carbon's in the center. He needs 8. He has 2, 4, 6, 8. So he's happy. His octet's fulfilled. Each hydrogen needs 2. And you see how they have 2. They all have 2. So all of their octets are fulfilled. So if all octets are fulfilled, and I've approached 0 in my math, then I have a valid structure and I'm done. Let's show a couple more that are a little bit more complicated. So for the next one, we're going to do N2. So first is do the math. Nitrogen is 5. I have another 5, or another nitrogen, so another 5. So that gives me 10 electrons total. You see how we've completed step 1. Electrons total. Now, we don't have one that can go in the center because there are only 2. So we're going to do nitrogen and another nitrogen. And we're going to start off by putting a single bond right here. Okay? Now, if I do that, a single bond has made me use 2 out of these 10 electrons. So I have 8 that I can use to fulfill my octets. Now, let's try to fulfill nitrogen's octet. Let's do, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. To fulfill both of their octets, we used a total of 12 electrons. 8 minus 12, however, is a -4 quantity. Now, look at step 5. You see where it says, if total electrons is a negative quantity, what we have here, then you check for CNOPs. Checking for CNOPs means, can these nitrogens get multiple bonds? And the answer is yes. Nitrogen's part of CNOPs. So what I'm going to do, oh God, please don't get the zoomies. Why do you always get the zoomies in here, Roo? Roo, come here. Hey, come here. Stop getting the zoomies. Help me teach chemistry, okay? Say, hey, Roo. All right, so anyway, we have nitrogen, and let's try a double bond. If we try a double bond, we are going to have to eliminate some of these things. Instead of 2 right here, we use 4. Okay, so instead of 2, we used 4. That gives us 6. Oh, yep, 6 here. And I have to use how many to make my octet fulfilled? Well, 1, 2, 3, 4, 5, 6. Do you see how I'm already going over my limit again? So let's try yet another bond. If I try yet another bond, then that means I will use 6 here. So let me get my pen to work that. So 6 electrons in my bonding. That means I have 4 left over, and those 4 are going to go on the outer edges to fulfill both nitrogen's octet. So this nitrogen now has 8. This nitrogen now has 8. And you see how now I've approached 0. I've double checked all of my octets, and they're good to go. So this is what you have to do, checking for CNOPs. That's if you get a negative quantity, if you like to keep on subtracting those values out. Let me show you an example for an expanded octet. And I'm trying to make this video as short as possible. I'm sorry if it's too long, but I want to make sure I'm very thorough with this. So let's do IF3. So IF3, first of all, iodine is 7, fluorine 7, and there's 3 of them, so it's 7 plus 21. So that gives me a total of 28 electrons total that I can use. So now I have to draw my structure. So I have IF3. So here's I in the center. Why is I in the center? It's the least electronegative out of the things that are there. Then I bond my fluorines. So I attach all my stuff. fluorine, fluorine, and another fluorine here. Okay, so there's all of my fluorines. Now I used 2, 4, 6 in that process. So 28 minus 6 is equal to 22. Now I'm going to fulfill the outer octets. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it took 18 to fulfill my outer octets. Now that I have that, 22 minus 18, that is equal to 4. You see how I have 4 electrons left over. It's not -4 now, it's a positive quantity here. So if total electrons is a positive quantity, check for the expanded octet and put the electrons on the central atom. Well, first of all, I see a problem because this iodine doesn't have an octet, first of all. He only has 6 electrons. So definitely 2 out of those 4 electrons needs to be attached to the iodine to fulfill its octet. Now I still have 2 electrons remaining. If that's the case, check iodine and ask yourself, can he have an expanded octet? Well, yes, he can. And the reason why is because he's in the 3rd energy level or greater, meaning he can expand his octet. He has orbital or d orbitals available. So these 2 little extra electrons are also going to go on the central atom. That's where you put them, because that central atom can have an expanded octet. So iodine actually has 2, 4, 6, 8, 10 surrounding itself, which is called an expanded octet. And that's okay, because iodine is in the 3rd energy level down on the periodic table. He has room for more. Okay, so this is how you do an expanded octet question. Now, the very last thing, I'm not really going to get into the nitty-gritty of it, but this very last one is NO+. Now, what does that plus mean? Well, the plus means that I have lost an electron. So where do you think that lost electron, where does it tie in? The answer to that is that it ties in with the math, okay? So nitrogen is 5. Oxygen is 6 electrons. And because that is a plus sign, I'm going to subtract 1 from the math. The -1 means that out of those electrons, he has lost 1 electron. So now my total electrons is 10, and then I go with the rest of my steps. What do you think you do if you have a negative? So what if it was NO-? Well, the answer to that, minus means gaining an electron, so I'm going to add an electron towards the end for my total math. Okay? If it's a positive, I subtract those electrons. If it's a negative, I add those electrons. I include it in the math at the very beginning, and then you just go on with your business like normally. I hope this was helpful. I hope you're able to do those Lewis structures pretty easily. It just takes lots of practice, and you have to be able to do a Lewis structure to be able to do the rest of this unit. So get to it. Have fun. I'm sorry Rue distracted us once again.